now, how we can relate volcano with the plate tectonic? What's the connections? Actually, the red dots shown in the location of the active volcanoes represents the location of the volcano around the world. And notice how the majority of the volcanism is focused in lines along the plate boundaries. For this reason, the area is known as the Pacific Ring of Fire. You can see the map of Pacific Ring of Fire. But why are all of the volcanoes located at the plate margins? Actually, the volcanoes can be formed in three different ways. Number one, via subduction. That means subducting slab dehydrates to form the new melt that will rise through the crust to erupt at the surface and create volcano. Number two is the rifting, and when two plates pull apart, magma rises and producing volcanic eruption at the surface and create volcano. And third one is the hotspot. Actually, hotspots do not necessarily occur along a plate boundary. So, hotspot volcanoes can form in the middle of tectonic plates. And now, actually, volcanoes are formed by three distinct ways. I already told that: subduction, rifting and hotspot. You can find all the answer of subduction, rifting and hotspot, how they actually occur in the diagram. And now hotspot. Actually, hotspot commonly form volcanic island chain like the Hawaiian Island, and these result from the slow movement of a tectonic plate over a fixed hotspot. Persistent volcanic activity as a hotspot will create new island as the plate moves the position of the old volcanic island from over the hotspot. And therefore, at one end, the island chain you see in the youngest, the most active volcanic island, and along the island chain the extinct volcano become older and more eroded. And this way, geologists can use hotspot volcano chain to track the movement of the tectonic plates through time. Actually, what are the hotspot volcanoes? Hot mantle plumes bleaching the surface in the middle of the tectonic plates, and thus result hotspot volcanoes. The Hawaiian Island chain are the example of hotspot volcano. The tectonic plates move over a fixed hotspot, forming a chain of volcano. Actually, the mantle plume is stationary. The tectonic plate moves over the hotspot, and the volcanoes get younger from one end to another, and thus seamounts, volcanic island, active volcano island, etc. are formed due to this volcanic activity. And now, what is the relation between the earthquake and plate tectonic? What's the connections? You can see the black dots in the map, the world, map of the world depict where the earthquake activity and the earthquake are not randomly distributed around the globe. Instead, they are occur in a linear patterns associated with the plate boundary. Therefore, we can say that plate tectonic and earthquake are very much related, and we know there are three types of plate boundaries: convergent, divergent and transform, and movements and slipping along each of these types of boundaries can form an earthquake. And depending on the types of movement, the earthquake occur in either at the shallow or deep level in the crust. And the majority of tectonic earthquakes originates in depth not exceeding 10 km. In subduction zone, where old and cold oceanic crust descends beneath another tectonic plate, deep focus earthquake may occur at much greater depth, up to 700 km. And these earthquakes occur at a depth at which the subducted crust should no longer be brittle, and due to high temperature and pressure, a possible mechanism for the generation of deep focus earthquake is actually faulting. Therefore, we can say that faulting, hotspot and plate movement, these are the major causes of earthquake. An earthquake may occur in volcanic regions and are caused there both by tectonic faults or by the movement of magma or hot molten rock within the volcano. And such earthquakes can be an early warning of volcanic eruptions. Actually, we can predict the volcano by the earthquake. At the boundaries of plates or between the plate boundary, friction causes them to stick together, and when build-up energy causes them to break, earthquake occur. And as with the volcanoes, earthquakes are not randomly distributed over the globe. You can see the figures show that where the earthquake actually formed, the transform fault, the subducting plate, the rising magma, the hotspot, everything. And now we can conclude that plate tectonic concepts as the earth is made up of three main layers: core, mantle and crust. To know the plate tectonic concept as well, this has to be known. Number two, on the surface of the earth are tectonic plates, and that actually slowly move around the globe. Number three, plates are made of crust and upper mantle. We can term this as lithosphere. Number four, actually there are two types of plate. One is continental plate and another is oceanic plate. Number five, there are actually three types of plate boundaries: convergent boundaries, divergent boundaries and transform boundaries. Number six, there are actually three types of plate movements: convergent, divergent and conservative or transform. Number seven, plate tectonics can give the scientific explanations of the various resultant reactions and landforms like earthquake, volcano, triple junction, hotspot, plate margin, plate boundary, active volcano, etc. Volcanoes and earthquake are very much linked to the margin of the tectonic plates, and these concepts explain the resultant landform, and the whole mechanism of the plate and plate tectonic help us to understand the concept of sea floor spreading and continental crust. Thank you and happy learning.